Alright, in this video we're going to look at the concept of limits. So limits actually is an idea or concept that forms one of the basic building blocks of the subject of calculus. So limits is a fundamental building block of the subject of calculus. Calculus itself is all about the study of rates of change. So, but here we're going to just focus on the subject of limits. So, let's consider the following function. So imagine we have the function y equal x squared minus 4 over x minus 2. So we can call this y, or we can call it f of x. We are going to be interested in the behavior of this function in the neighborhood of x equal to 2. So we're interested in the behavior of f of x in the neighborhood. Neighborhood is the same as vicinity. So we're interested in the behavior of this function around x equals to 2. In particular, we're going to be asking the question, what happens to f of x as x gets closer and closer to 2? So first, let's see what happens as x approach 2 from the left. We are going to tabulate the values of y as x gets closer and closer to 2. So let's have a little table here. So we're going to take a few values. Start with x equals to 1, x equals to 1.5, x equals 1.8, x equals 1.9, and then maybe 1.99. So let's start with when x is equal to 1. So we're going to plug in x is 1 here and there. So let's punch this in the calculator. So when x equals 1, we're going to have, so it's open brackets, 1 squared minus 4, and then all divided by 1 minus 2. Actually, in this case, you can work this thing out even without a calculator. The numerator is going to be negative 3. The denominator is going to be negative 1. So that tells us that y is going to be equal to 3. Okay, then let's see what happens to this when x is 1.5. So I'm just going to replace 1 by 1.5 here. Okay, and then evaluate. Then this tells us that when x is 1.5, y is going to be 3.5. Then I'm going to replace this by 1.8. So 1.8 here and 1.8 there. And this goes up to 3.8. Then let's go to x equal 1.9. So replace this by 1.9. And this goes to 3.9. So it looks like there's actually a linear correspondence going on here. So it appears that that's going to be 1.99, sorry, 3.99 when x is 1.99. So what are we noticing? We're noticing that as x is getting closer and closer to 2, y is getting closer and closer to 4. Okay, so mathematically, so we say the limit of our f of x is x squared minus 4 over x minus 2. So we say the limit of this function as x approach 2, from the left, so we say this limit is equal to 4, and notationally we can write this in a compact form as follows. So we write LIM for limit, so we say the limit of x squared minus 4 over x minus 2 as x approach 2 from the left, we denote by that little negative there. So we say this thing is equal to 4. So this whole thing here actually stands for everything in the inverted commas there. Right, now let's see what happens as x approaches 2 from the right hand side. So from the right we have, so we're gonna tabulate some values again, x, y here. So from the right we're going to start at 3, then we're going to go down to 2.5, 2.2, 2.1 and 2.01. Okay, so again, if we just punch this for 3, again we can do this without a calculator. It's going to be 3 squared minus 4, 3 minus 2, okay. 3 squared is 9 minus 4 is 5, 3 minus 2 is 1. So this is going to work out to 5. Then we go to 2.5, so I'm just going to replace that by 2.5 here and 2.5 there. So that works out to 4.5. So 4.5. Then when x is 2.2, so I'm just going to replace that by 2.2, and that works out to 4.2. And then when that x is 2.1, then x is going to be 4.1. I think you can confirm for yourself that when x is 2.01, y is going to be 4.01. So as this is getting closer and closer to 2, this again is getting closer and closer to 4, but from above this time. So we see that the limit is 2 again as x approaches 2 from the right. So we see that the limit of x squared minus 4 over x minus 2 as x approach 2 from the right. So this value again is equal to 4. Okay. So the notation this side is going to be very similar to what we have here, but the only difference is that this is going to be a plus now because we're approaching 2 from the right. So we write limit of x squared minus 4 over x minus 2 as x goes to 2 from the right is equal to 4. So we're saying that the limit from the right is 4 and the limit from the left is 4. By the way, the limit from the right is what we call the right-hand limit. So in that case, that's going to be the right-hand limit as x approaches 2. This one we call the left-hand limit, abbreviated LHL. This one we abbreviate RHL. So we are noticing here that the left-hand limit and the right-hand limit, these are equal. So they're equal and they're both equal to 4. Then we talk of the general limit, okay? So we say the general limit of x squared minus 4 over x minus 2 as x approach 2 is 4. Okay, and we express this as follows. So this time we write limit x squared minus 4 over x minus 2 as x approaches 2 is equal to 4 without any plus or minus there. So when that happens, then this is the general limit. All right. So before we look at some examples, we are going to make a definition. So let's make a definition. Okay, so the definition goes as follows. The limit of f of x as x approach a So which we write limit of f of x as x approach a. This is said to exist if and only if the three following conditions are met. First, the left-hand limit, which means a limit of f of x as x goes to a from the left. Okay, so first of all, the left-hand limit must exist. Secondly, the right-hand limit, which means the limit of f of x as x goes to a from the right, this must exist as well. Then the third condition is that the left-hand limit must be equal to the right-hand limit. So the left-hand limit must be equal to the right-hand limit. So this limit here must be equal to that limit there. Then we say the limit of f of x as x goes to a. So this one is the general limit here. It only exists if the left-hand limit exists, the right-hand limit exists, and those two limits are equal. Yeah, so before we go to some examples, let's just make a note here that the limit of f of x as x goes to a is all about the behavior of f of x as x approach a. Okay, so this is about the behavior of f of x as x approach a. Behavior of f of x as x approach a, and not necessarily about what happens to f of x at x equals to a. Okay, so and not necessarily about f of a. All right, and then the other thing that we're going to make a note of is this tabular analysis that we did here is called the numerical method or the numerical approach of analyzing the limit. So this is the numerical approach or the numerical method. So in this method, we simply plug in some numerical values and see what happens to f of x. Okay, we're now going to look at some examples, but before we look at the examples, okay, so we're going to start by stating a result for evaluating limits. This result is going to enable us to evaluate limits using a method called direct substitution. So the result says if f of x is a polynomial, or any other well-behaved function I'm going to qualify well-behaved in a moment, then the limit of f of x as x goes to a is simply the value of f at a. So what this thing is saying is that the limit is obtained by simply doing direct substitution. So the limit is obtained by performing direct substitution. All right. What do we mean by functions that are well behaved? Well, we're talking about functions that are continuous and they don't have any gaps or any jumps, or they don't have like vertical asymptotes, because if a function has got a vertical asymptote, then there is going to be a gap between the branch on the left hand side and the branch on the right hand side. So, and as we are going to remember, polynomials do not have any vertical asymptotes, but other functions that don't have vertical asymptotes include the exponential function, sine of x, cosine of x, etc. Okay, so for these functions, to evaluate the limit as x goes to a, we simply take a and plug it in there. So let's look at some examples. So suppose we want the limit as x goes to 2 of x squared minus 4x plus 7. So according to this result here, because this is a polynomial, the limit is simply going to be obtained by plugging in x is 2. So it's going to be 2 squared minus 4 times 2 plus 7. So this is going to be 4 minus 8 plus 7. So this is going to be 7 minus 4. So the limit is going to be 3. Right, in B, suppose we're looking for the limit of 5 minus 2x minus x squared as x goes to -3. So this time we're going to plug in -3. So 5 minus 2 times -3 minus -3 squared. It's going to be 5 plus 6 minus 9. This is going to be 11 minus 9. This is going to be equal to 2. In C, suppose we've got the limit as x goes to 4 of x over 2 minus 1 times square root 2x plus 1. This function is not a polynomial, but we are going to find that when we do direct substitution, the function in the neighborhood of 4 or at 4 is very much well defined. So let's see. So we're going to have 4 over 2 minus 1. Then we're going to have a square root of 2 times 4. So 2 times 4 plus 1. 4 over 2 is 2, minus 1 is 1, and this one is going to be square root 9. So this is going to be equal to 3. In D, suppose we are looking for the limit of 2 minus e to the x as x goes to 0. Remember we said e to the x is one of those well-behaved functions here, so we can evaluate this limit via direct substitution. So we simply plug in x equal to 0 here. Remember that e to the 0 is 1, so that's going to be 1 is our limit. Okay, so let's give you 2 examples to try out yourself. So suppose we're looking for the limit of 5 minus 4x minus x cubed as x goes to negative 2, that's e. Then f, suppose we're looking for the limit as x goes to 1, 3 minus 2x plus 2e to the power x minus 1. So if you'd like to have a go at those two, just pause the video and have a go at them, and then when you continue the video you can compare with our answers. Alright, we're now going to scroll down to our answers for E and F. So for E, it's a limit as x goes to minus 2. So if we simply plug in x is minus 2 here, this is what we get. And just notice here, be careful with this. It's going to work out to negative 8, and then minus negative 8 becomes plus 8. This one is obviously plus. So it's going to work out to 21. For f as x goes to 1, we plug in x is 1 here. It's going to be 3 minus 2 plus 2e to the 1 minus 1. This is e to the 0. So this is going to work out to 3. Right, okay, thank you for watching. Hopefully the video has been of help. You can subscribe so that you get notified whenever we post new material. Thank you.